The idea that the Earth is flat might seem like a relic of ancient times, but it has resurfaced in the modern world, capturing the imagination of thousands. To understand why this theory persists, we must travel back in time to its origins and explore how it has evolved over centuries. The story of the flat Earth belief is not just about science. It's about human curiosity, skepticism, and the eternal quest for understanding our place in the universe. In ancient civilizations, the concept of a flat Earth was widely accepted. The Egyptians, for example, envisioned the Earth as a flat disk floating in an endless ocean, with the sky held up by mountains at the edges. Similarly, the Babylonians believed the world was a flat plain surrounded by water with a dome-like sky above. These early cosmologies were shaped by limited observations and the lack of advanced technology. To the naked eye, the Earth does appear flat, and without the tools to measure its curvature, it was natural for people to assume it was. The ancient Greeks were among the first to challenge this view. Philosophers like Pythagoras and Aristotle began to argue that the Earth was spherical, based on observations such as the curved shadow it cast on the moon during lunar eclipses. By the time of the great navigators like Columbus and Magellan, the round Earth theory was widely accepted among scholars. The ability to circumnavigate the globe and the consistent patterns of stars in the night sky further solidified this understanding. So, how did the flat Earth theory make a comeback in the 21st century? The answer lies in the rise of the internet and social media. In the early 2000s, online communities began to form around the idea that the Earth might not be what we've been taught. These groups questioned the validity of scientific institutions, particularly space agencies like NASA, accusing them of fabricating evidence to maintain a global conspiracy. The Flat Earth movement gained traction through viral videos, forums, and conferences, attracting people who felt disillusioned by mainstream science and authority. One of the key figures in this modern resurgence is Samuel Shenton, who founded the Flat Earth Society in the 1950s. Shenton's ideas were largely dismissed at the time, but they laid the groundwork for a movement that would grow exponentially in the digital age. Today, flat earthers use platforms like YouTube and Facebook to share their theories, often citing evidence such as the lack of visible curvature from high-altitude balloons or the perceived inconsistencies in satellite imagery. But why does this theory resonate with so many people? For some, it's about distrust in institutions and a desire to question the status quo. For others, it's the appeal of being part of a community that challenges mainstream narratives. The Flat Earth movement taps into a deeper human need to feel special, to believe that we are privy to a hidden truth that others cannot see. As we delve into the origins of the Flat Earth belief, one thing becomes clear. This is more than just a debate about the shape of our planet. It's a story about how we understand the world around us, the power of skepticism, and the enduring allure of mystery. Whether you're a skeptic or a believer, the Flat Earth theory invites us all to question what we think we know. And that's a journey worth exploring. The Flat Earth theory is built on a series of arguments that challenge our understanding of the world. While these claims may seem outlandish to many, they are presented with conviction by those who believe in them. To understand the appeal of the Flat Earth movement, we must examine these arguments and the reasoning behind them. What do Flat Earthers believe? And why do they reject the overwhelming scientific evidence that the Earth is round? One of the most common arguments is based on perception. Flat Earthers argue that, to the naked eye, the Earth appears flat. When we look at the horizon, whether from the ground or a high-altitude vantage point, there is no obvious curvature. They claim that if the Earth were truly a sphere, we should be able to see its curvature more clearly. However, this argument overlooks the fact that the Earth is so large that its curvature is only noticeable from very high altitudes, such as those achieved by airplanes or satellites. Another key claim is the distrust of space agencies like NASA. Flat earthers often accuse these organizations of fabricating evidence, such as photos of the Earth from space, to perpetuate a global conspiracy. They argue that the images of a round Earth are digitally altered or created using CGI. This skepticism extends to the entire space industry, with flat earthers questioning the validity of moon landings, satellite technology, and even the existence of astronauts. Flat earthers also challenge the concept of gravity. Instead of accepting gravity as the force that keeps us grounded, they propose an alternative explanation. The Earth is accelerating upward at 9.8 meters per second squared. According to this theory, it's not gravity that keeps us on the ground, but the constant upward motion of the Earth. This idea, while creative, contradicts the fundamental laws of physics and ignores the vast body of evidence supporting the existence of gravity. One of the more visually striking claims is the idea of a dome that covers the flat Earth. Flat earthers believe that the sky is a solid structure, with the sun, moon, and stars moving across its surface. This dome, they argue, explains why we can't see beyond a certain distance and why space travel is impossible. However, this theory fails to account for the vast amount of astronomical data that supports the idea of an infinite, expanding universe. Flat earthers also conduct their own experiments to prove their claims. For example, they use lasers and levels to measure the flatness of large bodies of water, such as lakes or the ocean. They argue that if the Earth were curved, these measurements would show a noticeable dip. However, these experiments often fail to account for factors like atmospheric refraction and the limitations of their equipment. Despite the scientific community's efforts to debunk these claims, flat earthers remain steadfast in their beliefs. For many, the appeal lies in the sense of community and the thrill of questioning mainstream narratives. The Flat Earth movement is not just about the shape of the Earth. It's about challenging authority, seeking alternative truths, and finding meaning in a world that often feels overwhelming. As we explore the arguments of flat earthers, it's important to approach them with an open mind and a critical eye. While their claims may seem far-fetched, they offer a unique perspective on how we understand the world around us. Whether you agree with them or not, the flat earth theory invites us all to question what we think we know, and that's a journey worth exploring. The flat earth theory may captivate the imagination, but it stands in stark contrast to centuries of scientific evidence that confirms the Earth is a sphere. From ancient observations to modern technology, the round Earth model has been tested, proven, and universally accepted by the scientific community. In this chapter, we'll explore the overwhelming evidence that debunks the flat Earth theory and examine how science explains the phenomena that flat earthers often misinterpret. One of the most compelling pieces of evidence for a round Earth is the photographic proof from space. Since the mid-20th century, satellites and astronauts have captured countless images of our planet, all showing a spherical Earth. The iconic blue marble photo taken by Apollo 17 in 1972 is just one example. Flat earthers often dismiss these images as fabrications, but the sheer volume of consistent data from multiple countries and space agencies makes this claim difficult to sustain. If there were a global conspiracy to fake these images, it would require the cooperation of thousands of scientists, engineers, and governments, a scenario that defies logic. Another undeniable proof of Earth's curvature comes from observations made during eclipses. During a lunar eclipse, the Earth passes between the Sun and the Moon, casting a shadow on the lunar surface. This shadow is always round, which would only be possible if the Earth were spherical. If the Earth were flat, the shadow would vary in shape depending on the angle of the Sun, something that has never been observed. The concept of gravity also plays a crucial role in understanding Earth's shape. Gravity pulls objects toward the center of mass, which naturally results in a spherical shape for large celestial bodies like planets. Flat earthers propose that the Earth is accelerating upward to simulate gravity, but this idea contradicts the laws of physics. If the Earth were constantly accelerating at 9.8 meters per second squared, it would have reached the speed of light long ago, a physical impossibility. The behavior of celestial bodies further supports the round Earth model. As ships sail away from the shore, they gradually disappear hull first, with the mast being the last part visible. This phenomenon, known as sinking ship effect, is a direct result of Earth's curvature. Similarly, the stars visible in the night sky change depending on your location. In the northern hemisphere, Polaris, the North Star, remains fixed, while in the southern hemisphere, it's completely invisible. This variation is only possible on a spherical Earth. Modern technology has also provided irrefutable evidence. GPS systems, for example, rely on a network of satellites orbiting a spherical Earth. These satellites calculate positions based on the curvature of the planet, and their accuracy would be impossible if the Earth were flat. Similarly, airline flight paths are plotted using great circle routes, which are the shortest distances between 2 points on a sphere. These routes would make no sense on a flat Earth. Despite the overwhelming evidence, flat earthers often misinterpret or dismiss scientific explanations. For example, they argue that the horizon always appears flat, even from high altitudes. However, this is due to the vast scale of the Earth. Its curvature is only noticeable from extremely high altitudes, such as those achieved by spacecraft. They also claim that water always finds its level, suggesting that oceans would fall off a spherical Earth. In reality, gravity ensures that water conforms to the shape of the planet, creating a level surface relative to the curvature. The scientific method, which relies on observation, experimentation, and peer review, has consistently supported the round Earth model. While the flat Earth theory may appeal to those who distrust authority or seek alternative explanations, it fails to provide a coherent framework that accounts for the vast array of observable phenomena. As we explore the science behind Earth's shape, it's important to approach the flat Earth theory with curiosity and critical thinking. While it may seem like a harmless belief, it highlights the importance of scientific literacy and the dangers of rejecting evidence-based knowledge. The round Earth is not just a fact. It's a testament to humanity's ability to understand the universe through reason and exploration. The flat Earth theory is more than just a fringe belief. It's a cultural phenomenon that reflects broader societal trends. From its resurgence in the digital age to its influence on popular culture, the Flat Earth movement has sparked debates about trust, authority, and the nature of truth. In this chapter, we'll explore why people believe in the Flat Earth theory, its impact on society, and what it reveals about the challenges of navigating an increasingly complex world. One of the most intriguing aspects of the Flat Earth movement is its ability to attract followers from diverse backgrounds. For many, the appeal lies in the sense of community and belonging. Flat Earth conferences, online forums, and social media groups provide a space where people can share their beliefs without fear of ridicule. These communities often emphasize critical thinking and skepticism, encouraging members to question mainstream narratives. However, this skepticism can sometimes veer into outright rejection of established facts, creating an echo chamber where alternative theories thrive. The rise of the internet has played a significant role in the resurgence of the Flat Earth theory. Social media platforms like YouTube and Facebook allow flat earthers to share their ideas with a global audience, often using compelling visuals and emotional appeals. Algorithms that prioritize engagement can amplify these messages, creating a feedback loop that reinforces belief in the theory. This digital landscape has made it easier than ever for misinformation to spread, challenging traditional sources of authority like scientists and educators. Flat earthers often frame their beliefs as a rebellion against a corrupt system. They argue that governments, scientists, and media organizations are part of a vast conspiracy to deceive the public. This distrust of authority resonates with people who feel disillusioned by societal institutions. In a world where misinformation and scandals are commonplace, the idea of a hidden truth can be deeply appealing. For some, believing in the Flat Earth theory is a way to reclaim a sense of control and agency in an uncertain world. The Flat Earth movement has also had a noticeable impact on popular culture. Documentaries like Behind the Curve explore the lives of flat earthers, offering a glimpse into their motivations and beliefs. Comedians and satirists have used the theory as fodder for jokes, while musicians and artists have incorporated flat earth imagery into their work. Even major brands have capitalized on the trend, with companies selling flat earth-themed merchandise. While these portrayals often mock the theory, they also contribute to its visibility and staying power. However, the Flat Earth theory is not without its dangers. By rejecting established scientific knowledge, flat earthers undermine public trust in science and education. This skepticism can have real-world consequences, such as the spread of anti-vaccine sentiments or climate change denial. The Flat Earth movement highlights the importance of critical thinking and media literacy, as well as the need for scientists and educators to communicate their findings in accessible and engaging ways. Despite its flaws, the Flat Earth theory offers valuable insights into the human condition. It reminds us of our innate curiosity and desire to understand the world around us. It also underscores the challenges of navigating an information landscape where facts and fiction are increasingly difficult to distinguish. In a sense, the Flat Earth movement is a reflection of our times, a response to the complexities and uncertainties of modern life. As we conclude our exploration of the Flat Earth theory, one thing is clear. It's more than just a debate about the shape of our planet. It's a story about trust, community, and the search for meaning in a rapidly changing world. Whether you view it as a cautionary tale or fascinating cultural phenomenon, the Flat Earth theory invites us all to question what we think we know and to consider the broader implications of our beliefs.